Okay, this one's a little bit tricky, so pay attention. So they have said that g of x is f of x, and let's just write that. So according to the definition of f of x, it is 1 plus f of x in the interval 0 to 2 and 3 minus f of x in the interval 2 to 3. Okay. So to solve such problems, the general way is just draw a graph, and from there you can see how the graph behaves at various points. So it's a graph of x and f of x. So let's see. According to the definition of f of x, when x is between 0 to 2, okay, so for x equal to 0, f of x is 1, and for x equal to 2, it is 3. So it's like this. And for x equal to 3, it is 0, and x, okay, so the slope is also minus 1, so we can just draw it like this, and this will be a hollow circle over here because it is given that the definition is 1 plus x when x is less than or equal to 2. So the value at x equal to 2 will go over here. So this is 3, 2, 1, 1, 2, 3. Okay, fine. So understand what we have to do here. To find the discontinuity of x, we have to express, right now g of x is in the form of f of x, right? The two definitions of the function are in the form of f of x. So we now have to write g of x in the form of x, only x. So let's do that. So we can clearly see from here and here that the values of f of x are in two intervals. So that is between 0 to 2. So it is like this one. Suppose this is first part, then the first part will correspond to this, and 2 to 3. If this is the second part, then the second part is over here. So now what we have to do is we have to see the values of f of x and find the corresponding values of x for that. So let's see, first let's start with the easy one. Let's see for interval for f of x between 2 to 3. So it is this part, f of x between 2 to 3, and we know that this is x minus 1, that's the graph of x plus 1, sorry, that's the graph of x plus 1. And if you see the corresponding values of x, it is this, right? It is between 1 to 2. So let's write g of x. So according to this definition, it is 3 minus f of x, but now we have to find out f of x. So we have seen that f of x is between 1 to 2. So let's apply the definition of f of x for x between 1 to 2. It is 1 plus x. So it will become 3 minus 1 plus x. Okay. And this is for the interval open interval 1 to closed interval 2 of x. We are writing down the intervals of x now, not f of x. So don't get confused. Now next, let's see for f of x between 1 and 2. So it is this part, and the corresponding values of x are 0 to 1. So now it is closed interval 0 to closed interval 1. and f of x is between 1 and 2, so this definition will apply, 1 plus f of x. So let's write, it's 1 plus f of x. But what about f of x? X is between 0 to 1, so this definition will apply. So that will become 1 plus x. So this is the definition of g of x for closed interval 0 to closed interval 1. So the next part is obviously this one, when f of x is between 0 and 1 and the corresponding values of x are 2 to 3. So when f of x is between 0 and 1, again this definition will apply because of this. But x is between 2 and 3, so this definition will apply for f of x. So it is 1 plus f of x, that is equal to 1 plus 3 minus x, and it will be from open interval 2 to closed interval 3. Okay, so g of x is basically now defined in this way. Now let's check the points for continuity. We will have to check continuity at all those points where the definition of the function is changing. So it is at 1 and at 2. So the positive side limit should be equal to the negative side limit. So let's check for 1 first. So finding the limit of g of x using this definition, it will be 3 minus 1 minus x, so that is 2 minus x, so that is 2 minus 1, that's 1. So from positive side is equal to 1. From negative side, so it will become this. So 1 plus 1 plus 1, that's 3. So f is 3. So it is not equal, so the function is discontinuous at x is equal to 1. Now let's check for 2. So using this definition, it will be 1 plus 3, 4 minus 2, 2. Therefore f of 2 from one side is 2. Now let's check using this definition. So 3 minus 2 plus 1 is 3, 3 minus 3 is 0. So f of 2 from the other side is 0. So again, the left hand side limit is not equal to right hand side limit. So discontinuity is there at 2 as well. And yeah, I think our sum is complete.